Hello and welcome back to my YouTube channel. My name is Professor Gavala, and today we're going to be doing the derivation of the integrator circuit located to the left here. And essentially what we want to do is simply find a solution for V out of t given the circuit. So before we begin, we want to define the integrated circuit, and the definition says that the integrator is an op-amp circuit whose output is proportional to the integral of the input signal. So pretty standard. And we need to note that this input signal must be alternating in order to pass through the capacitor, right? Because remember, in a capacitor, and I've made a video on this, so please feel free to check that out, it blocks DC or direct current, and it allows AC or alternating current. All right, so let's go ahead and solve this circuit. Okay, so in order to solve this, we need to notice a couple of things about an ideal op-amp in this situation. We're going to say then that in an ideal op-amp, VP is approximately VN, or the voltage at this node is equated to the voltage at this node. So if this is 0 volts because it's connected to ground, this is also 0 volts. All right, so let me say this is my first equation. My second equation is I'm going to solve for this VC of t and say that VC of t is equals to 0, right? Because 0 comes from here, minus V out of t, minus V out of t. So this is just equated to negative V out of t. Okay. So let me go ahead and start writing what's called the KCL for this circuit. And I'm going to say then that IR must be equals to IC. Essentially, the current coming into this node has to equate the current going out of it. IR is basically Vn of t minus 0 over Rn. And this has to equals to IC is the current across the capacitor. And from a previous video, which I will link in the top right hand corner of this video, IC is equals to the capacitance times the change in VC of t over dt. But we know that VC of t is simply negative V out of t. There should be an F here. So then this is equated to CF D minus V out of t over dt. What I'm going to do is I'm going to multiply both sides of this equation by a minus dt over C feedback. All right. And on the top here, I'm going to say then that this CF cancels out with this CF, and this DT cancels out with this DT, and this negative cancels out with this negative. So I can rewrite my equation. I'm going to write my dV out on the left-hand side this time. So this becomes dV out has to equate to minus 1 over Rn CF times Vn of t times dt. Okay, so what I'm going to do now is I'm going to integrate both sides from 0 to t. This goes from 0 to t. So then this becomes V out of t minus V out of 0 has to equal, I'm going to pull out the minus 1 over Rn CF because that's just a constant. And I'm going to integrate from 0 to t, Vn of t dt. Since this here is my initial condition, I can move it to the right-hand side. And this becomes V out of t is equated to minus 1 over Rn CF, integrated from 0 to t, Vn of t dt, plus V out of 0, or my initial condition. And this here is the final equation for your integrator circuit. If you have any questions about the video, please leave them down in the comment section below and I'll be sure to get back to you. If you like the video, please give it a thumbs up and please subscribe to my YouTube channel. If you like the content that it's providing, it really helps the algorithm. Thank you.